Hello students, in this video today we are going to discuss about simple microscope and angular magnification. So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. If you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. That's my Insta ID. You can follow me on Insta. So now let's start. So what do you mean by simple microscope? A simple microscope is nothing but a conversion lens of small focal length. Okay, so let me write that. So a simple microscope or it is also called magnifier. Okay, is a converging lens of small focal length, right? So this is nothing but a converging lens of a small focal length. That means converging lens means convex lens. Okay, now what is angular magnification? What is angular magnification? So you have got the idea about linear magnification in class 10. You have already got in school level. Okay, so now let me clean this page, let me clean these things. Okay, so now you see, let me explain what is angular magnification. Now you see, suppose if you have, let me show you something, just give me a second. Okay, now you see, suppose here we have an object. Okay, this is A and this is AB, an object, and this is, suppose, eye of the observer. This is your eye, suppose. Okay, and the object is at a distance equal to D, which is the least distance of distinct vision. Least distance of distinct vision. Okay, so let me draw the diagram. Let me make the diagram larger. Okay, so that I can explain properly. So suppose this is your eye. Okay, this is your eye, and this is the position of the eye, and this object is at a distance equal to D, which is least distance of distinct vision. That means the nearest point, the closest point, the point which is the closest to eye, up to which we can see an object clearly. Okay, clearly, without any pressure on or without any stress on our eye. Okay, then the angle made by this object at the eye lens, okay, that is, let it be suppose alpha. Okay, now this angle, and if we introduce lens between the eye and the object, and so that the eye is very close to the lens, let me introduce lens here, and such that the object is now not at a distance of least at a distance equal to least distance of distinct vision. Now it is between optical center and the focus of the lens. So it must have two foci, f1, f2, as it is lens, right? Now you see, the eye is very close to this lens. This eye is very close to this lens, right? Then, so we have placed the object in such a way that the image formed by this lens of image of this object, right? Image of this object formed by this lens. So let me draw it properly. Just give me a second. Just give me a second. Okay. just one more second. Okay, now the image formed by this lens is formed at a distance is equal to least distance of distinct vision. Now the image is at a distance of least distance of distinct vision. Okay, now it is at equality. Now the angle formed by this image at this eye is almost equal to this angle. Okay, this is angle beta. This is lens, not the eye, but eye is very close to lens, so we can consider this angle is the angle formed by this subtended by this object, this image at the eye. Okay, so this is beta. Now this the ratio between these two angles, ratio of these two angles, beta and alpha, that is the angular magnification, that is the angular magnification, or also called magnifying power or magnifying power, right? So let me explain it again. Suppose this is an object AB. Okay, this is the object AB now. So before the lens was introduced, the angle made by the object at the eye is alpha when this object is at a distance equal to d, which is nothing but least distance of distinct vision. Then a lens L is introduced such that the object is in between the focus and the optical center, so that the image is formed at a distance equal to d, which is the least distance of distinct vision. In that case, the angle subtended by this image at the eye, or you can say this angle, which is actually this eye is very close to the lens, so that's why you can consider this angle is the angle subtended by the image at the eye. So that angle is beta, and ratio of these two angles, beta and alpha, is the angular magnification. Hope you have understood this. Now let me write the definition of angular magnification. So angular magnification or magnifying power of a simple microscope is defined as the angular magnification or magnifying power of a simple microscope is the ratio of the angle subtended by the image at the eye to the angle subtended by the object subtended by the object at the eye. Okay, when both are placed at the least distance of distinct vision, right? Independently. First, before the lens was placed, the object was placed at a distance of least distance of distinct vision, and the angle subtended by it at the eye was measured. Then lens was introduced so that the object is formed at the least distance of distinct vision. Okay, so that image is formed at the distance equal to least distance of distinct vision, and then the angle subtended by the image is if it is beta, and angle subtended by the image and object are supposed respectively beta and alpha. This is the angle subtended by the image beta, and this is the angle subtended by the object is suppose alpha. Then this ratio gives the angular magnification or magnifying power. So let me obtain the mathematical expression for angular magnification or magnifying power. Let me take a new slide so that I can show you. So here you see, suppose we have two figures. These are the two figures. Let me consider this. This is figure 1 and this is figure 2. Okay, so here we have AB is an object. Suppose AB be the object here, and of height its height be suppose h. So let me take the height of the object be h. Okay, so let me write it properly. This is the height of the object, okay, AB, right? And A dash B dash be the image of AB in figure 2, right? So this is suppose figure 2. Okay, so now you see, let us consider that angle subtended by the object when the lens was not introduced in figure 1 and the object is at a distance d, which is the least distance of distinct vision. D is the least distance of distinct vision. Okay, now you see, and let us consider this angle is the angle made by the image at the eye, as eye is very close to the lens. This angle is suppose beta. Let this angle be beta. So let me write here, just wait, just give me a second. Okay, here is the angle beta. This angle is beta. Okay, this is angle beta. Okay, so now let us write, let alpha and beta be the angles subtended by the object and the image at the eye respectively when both are placed at a distance equal to d, which is the least distance of distinct vision, which is the least distance of distinct vision. So at a distance d, which is the least distance of distinct vision, okay, when they are placed at this distance independently. Okay, so here I have drawn two figures. Okay, so first object is placed at a distance of least distance of distinct vision, then lens is introduced, then the image is formed at the distance d, which is the least distance of distinct vision independently, right? Okay, so hope you have understood this. Take the screenshot or you can pause the video or note it. So now let me take a new slide. Okay, and let me consider h dash be the height of the image. Let me consider the size of the image is suppose h dash be the size of the image, be h dash. Okay, let me write it. H dash is equal to size of the image, right? Hope you have understood this. Now let me take a new slide. So here I have drawn the figure 1 and 2 again. Okay, so according to the definition of magnifying power or angular magnification, so let me write here MP, magnifying power or angular magnification. So according to the definition, it must be equal to beta by alpha. So beta is the angle. So here you see in this figure 2, beta is the angle subtended by the image at the eye. Here eye is not drawn, actually eye is very close to this lens. Okay, very close to this lens, so that's why this angle, actually this is the angle subtended by, if this is the eye, this is the eye, then angle subtended by the image is this one. Okay, but here the lens is very close to the eye, so I have considered this angle on is the angle subtended by the image is beta. I have considered this angle beta, this one. Okay, because this angle, and if the eye is here and this angle, these two are almost equal. Okay, so hope you have understood this. So now you see, for very small angle alpha and beta. Okay, let me consider that this is a small object. For a large object, this angle will be very large, but for simplicity, let me consider small objects. Okay, since alpha and beta are very small, so therefore we can write that beta is approximately equal to 10 beta and alpha is approximately equal to 10 alpha, right? We can write that. So that's why this formula will be equal to then we're gonna get MP, this beta, instead of beta we can write 10 beta, right? And instead of alpha we can write 10 alpha, right? 10 alpha, right? So hope you have understood this. So now you see that here, from these two triangles, from this triangle first, let me take this triangle. From this triangle AB, this is suppose E. Okay, from this triangle ABE, or simply let it be O. Okay, if you take 10 theta, then this is the height of the object and this is the least distance of distinct vision. We know 10, if we consider 10 alpha from this triangle, 10 alpha, we know that perpendicular by base, that is h by d. Here h is the perpendicular, d is the base here, right? Hope you have understood this. So now, instead of 10 alpha we're going to write, h by d. And similarly from this triangle you can see a dash b dash o. From this triangle, if you take 10 beta, this angle is beta. Here you can see this angle is beta, this angle, right? That means this angle is beta. So if you take this triangle, then here h dash is the perpendicular and d is the base. So 10 beta can be written as h dash by take h dash by d, Here dd will be cancelled, d gone. So what we have got here, we have left with h dash by h, and h dash by h dash is the image of size of the image, and this is the size of the object, and the ratio of the size of the image and the size of the object is nothing but the linear magnification. Let it be small n. This is suppose equation number 1, that is the linear magnification. This equal to linear magnification, right? So hope you have understood this. Let me write it properly. Linear magnification. Okay, now you see, so what we have got, we have end up getting MP, that is angular magnification, is equal to M. This is equation number 1. That is what we have got, right? Hope you have understood this. So this h dash by h, is nothing but M, right? So hope you have understood this. Now we also know that the linear magnification for a lens, we know that linear magnification, let me write it properly, linear magnification small m is equal to v by u. Hope you know this. So v is the image distance, and u is the object distance, right? Okay, now let me copy this equation number 1, and let me copy this equation as well, m is equal to v by u. So let me take a new slide. Let me copy this equation first, and let me take a new slide. So here you see, these are the steps that we have got. Now let me copy the diagram also. Let me copy the figure 2 as well. Let me copy figure 2. Not only 2, let me copy both the figure. Okay, let me paste here 1 and 2, both the figure. Okay, then it will be better to explain. So now here you see what we're going to do, that using sign convention, if we use the sign convention, so if we use the sign convention, this side is negative, this side is positive, right? So here you see, that's why we're gonna put, instead of u, this is the image object distance u, so, and the image distance is equal to here d. Okay, so as this side is negative, we're gonna take negative. So what we're gonna put v is equal to minus d, u is equal to minus u. Then what you're gonna get, m is equal to v minus v by minus, so instead of v we're gonna put d, okay, minus d by minus u. That's what we have got. So now d by u, so here minus gone, so it's become d by u, so it's become d by u. Now from equation number 1, that we have seen that angular magnification is equal to the linear magnification. So instead of m, we're going to put capital MP, so that is the angular magnification, d by u, from equation number 1, right? So hope you have understood this. Now from length formula, let it be equation number 2. From length formula, just simply write length formula. Length formula was 1 by v minus 1 by u is equal to 1 by f. Okay, now let me copy the length formula and equation number 2, and let me take a new slide. Okay, let me take a new slide. So here are the 2 steps that we need now. So now you see, if we again let me go back to the previous slide. If we again use this sign convention, sign convention again, okay, let me use this sign convention again, then here we're gonna have 1 by v, instead of v we're gonna put minus d, 1 by u, instead of u we're gonna put minus u, then this minus it's gonna be plus, right? Hope you have understood. Minus, that's gonna be plus. So 1 by u is equal to 1 by f, and this implies 1 by u is equal to 1 by f plus 1 by d. That's what we're gonna have. Now let us divide both sides by d, multiply both sides by d. So what we're gonna do, we're gonna multiply both sides by d. Okay, so let's multiply d on this side and on this side as well. Then what we're gonna get, d by u is equal to d by f plus 1, right? So that's why, let me write here, that's why you see d by u is the angular magnification. So from 2 we can write that equation 2 implies that MP magnifying power or angular magnification, which is equal to du, which is also equal to 1 plus d by f. 1 plus d by f. That's what we have got. That is the expression for angular magnification. This is the expression for angular magnification. Angular magnification. Now you see, if the object is at focus, if the object is at focus, okay, if the object is at focus, then you see, then when you keep the object at focus in front, in case of a convex mirror, if this is the focus, if you keep the object at focus, then image is always formed at infinity. So hope you know this thing, it forms at infinity, right? So hope you know this. So that the object is at focus, then image will be formed at infinity. Then the image will be at infinity, and we know that for a normal eye, the infinity is the far point, so that maximum distance we can see is infinity. Okay, for a normal eye, far point is infinity. For a normal eye, far point is infinity. So now again putting u is equal to minus u, and now v is equal to infinity. If we put v is equal to infinity, or if you put minus infinity, that's supposed to be minus infinity. Okay, so in that case, from the lens formula, what we're gonna get, instead of v we're gonna put minus infinity, then minus 1 by minus u is equal to 1 by f. Then this u will be obviously equal to f, right? Because we are putting we have placed the object at focus, so definitely u will be f, u will be equal to f. So if u is equal to f, right, then what we can do here, you see that instead of writing u is equal to f, let me write this way: 1 by u is equal to 1 by f. Now multiply d with this and this also on both sides. Then what we're gonna have, so here we have got, this implies 1 by u is equal to 1 by f. We have multiplied d on both sides, so then we got d by u and d by f. D by u is nothing but the angular magnification, so angular magnification or magnifying power. So now it's become d by f, right? So this is the expression, okay, when the object is at focus. And maximum magnifying power or maximum angular magnification for simple microscope is less than equal to 9. So this is the maximum angular magnification. Remember this data. Okay, so maximum angular magnification for a simple microscope, maximum angular magnification for simple microscope is less than equal to 9. Remember this data. Okay, So hope you have understood this. Thank you for watching. See you in the next video. Bye bye.